you guys, I get to be quiet, don't I? And you get to fall asleep. But still, in your deep, deep REM sleep.
Times g prime of x plus g of x times f prime of x.
I heard that. Do you guys agree?
Yes.
Well, you know what? I thought we were supposed to talk about integration. I just recall something from differentiation as a process. But integration amounts to anti-differentiating along the way. And I think anti-differentiating is just the reverse direction of differentiating. So I think if I were to take this result and integrate it, somebody tell me what the result should be. Yeah, do you mind if I don't write the constant c? Only because I still got the integration symbol, so I assume the constant's going to be over there. Or shall I rewrite this? I guess that suggests that f of x times g of x is equal to, look at the right-hand side. Let me split up this integral. Let me write this as an integral of f of x, g prime of x with respect to x, plus the integral of my g of x, f prime of x with respect to x. You guys, I'm just playing, and everything I'm doing is very simplistic. But you know what? I'm wasting ink. There's too much writing. Can I abbreviate this? Put u equal to f of x. And what's du?
dx.
And if I allow v to be equal to g of x, then how would you relate dv to dx?
G of x prime dx.
Yeah, it's g prime of x dx. If you guys allow me to make a substitution, committing to the substitution, doesn't that tell me that u times v is equal to the integral of u dv plus v du? Or maybe, I can isolate one of these integrals, like how about the first one on the right-hand side? Doesn't it tell me that the integral of u dv is equivalent to nothing more than uv minus the integral of v du? You know what this suggests? It suggests maybe if you guys have an integral that's a product of two things, and you can't anti-differentiate right off the top of your head, or you can't even make a nice, clean, easy u sub, then maybe we can use this formula to rewrite this integral as an expression involving a completely other integral that might be easier to integrate. In fact, this becomes so important. Can I give it a name? Look at my box. I'm going to refer to this as my integration by parts formula. Now, when I came to class the first day of class of summer session, I made the proclamation and even verified what I said, namely that when it comes to the substitution method, it's just worth walking in the reverse direction of the chain rule of differentiation process. Likewise, you can think of this integration by parts formula as nothing more than the reverse process of the product rule for differentiation. But again, the key, the utility, is that it allows me to take my integral and rewrite an expression involving another integral, and perhaps that second integral might be easier to handle. So can we take a peek? Here's an example of an integral that I think before this integration by parts, is relatively nasty. I do not think equate u sub is going to clean up that integrand in any way significantly. And I certainly can't rattle off the top of my head an antiderivative for the product of those two functions. As a matter of fact, I think the key problem here is I've got the product of two functions, one of which is algebraic, one of which is transcendental. And since the u sub doesn't seem to apply here, I think integration by parts by far is the way to go. So, you guys allow me. Do you think with this first example, can you guys just kind of relax it and just watch me go through the flow? So watch me carefully. I think it was the integrand position as a product of U and DV. So I will let U be, I don't know, how about, how long U be sine of x? And DV to be equal to x dx. Doesn't that mean that du is cosine of x dx? And v is going to be equal to 1/2 x squared. If you guys think about it, I think what the real problem with this integral is I got the factor of x in there. Humor me. Yes or no answer. If there's no factor of x, can I anti-differentiate piece of cake? Yeah, I can. Now you guys watch me in applying this integration by parts formula. I think this integral can be written as a product of u and v minus the integral of my v du, which in this case is 1/2 x squared cosine of x dx. Yes or no response? Doesn't that make my life a lot easier? Doesn't that make my life a lot easier?
Yes.
How many yeses?
No.
So,
Can't you let u equal
well, it doesn't
that?
really make a difference.
Well, then your derivative is 1.
Beautiful. I think my answer is lousy. I do not think I've cleaned things up nicely. Remember what I just said? I said if I didn't have a factor of x in there, I can integrate sine of x piece of cake. And look what I've done with my integration by parts formula. I made the integram worse than it was. Because now x is risen to an x squared power. Do you see my point? Well, that must mean my assignments for u and dv are completely backwards. Watch, no tricks this time. I now allow u to be x, dv to be, is it sine or cosine? Sine of x. Committing to these two assignments, I do think du is this beautifully clean. And v is going to be equal to this. Now you have to confess, that second integral in the integrand's position is going to have a product of these two beasts. That means I can anti-differentiate cosine of x just like that. And now I will rewrite this integral as a product of my new u, my new dv, which in this case is negative x, cosine of x, minus the integral involving my v du, which is negative cosine of x with respect to x. As a matter of fact, if you look logically what I've just done, sort of like I've reduced the order to which x is being raised. This is a type of reduction of order technique. I use that phrase reduction of order a lot. Well, maybe not yet, but I certainly will use it a lot, particularly with memory, right? And I want a yes or no answer. Piece of cake? Yes.
Yes.
Yeah, it sure is. And that's going to give me negative x cosine of x. Is it a plus sine of x? No. Nobody there. No, my signs are okay. I mean, if you differentiate cosine, you get negative sine. But go this way. Differentiate sine, you get positive cosine. You guys, how many of you in here know something about electronics? Just a few of us. I won't waste time, but for those few, is that really our mathematical model describing something like voltage? And is this just going to be standard sinusoidal wave you get on this little stuff?
Adding signs to it. It's something out of there.
I think it's more tied into the fact that this darn x is in the way, taking the place of my amplitude. I think for this sinusoidal wave is steady state, but this one is not steady state, is it? It's actually increasing its amplitude. It's not a sinusoidal wave because it doesn't have a constant amplitude. You guys ever heard of? Yeah, I'm sorry, Dave.
Oh, no, it's fine. Graphically, when there's, I was watching a video yesterday in regards to symmetry of functions, and when you put sand on whatever and you amplify the sound to some decibel volume, it creates geometric signs or geometric designs of some sort. like pretty little squiggles,
yeah.
loops and stuff. Does that have anything to do with the actual functions or the actual?
I think if you really want to talk about mathematically describing the sand patterns you see in that particular application, you really have to represent the curve parametrically. Because if you consider x-axis here, y-axis here, and just look straight down the speaker, you can see the sand patterns. It's not going. You're not going to see y or x typically being represented as a function of the other variable. And so you have to split this up into terms of multiple functions with a parameter, describing a function for x and a function for y. So I think that's much more complex than I have here. I might get this word wrong. I can never remember these towns that connect Tecumseh and Narrows. Have you heard of Tecumseh and Narrows Bridge? You never heard of Tecumseh and Narrows Bridge in Washington? Where you see the video, the bridge is kind of shaking more and more. What's that? Tacoma Narrows?
Yeah.
I could have it wrong. But the point is, that was a really good example where this actually happened. Where the amplitude increased without bound. Where the natural frequency of the bridge, the way it was constructed, was augmented by the frequency in which the air was coming in on the bridge. It was a storm.
Was that the one that just fell down?
Yeah, it just kind of
Okay.
waved more and more and more and just completely fell down. You know, I just came across so many interesting stories in that bridge. Whatever city was responsible for building it took out insurance. And they felt like they couldn't afford the insurance anymore. They're going to cancel it. It was already a decision made by the city council. And the bridge collapsed, I think, exactly 1 week before they canceled the insurance. So they got all the money. No, they never did. The insurance man never put the money, sent the money to the company. He pocketed all of it. Yeah, did a lot of prison, did some prison time for it. A local bank was so proud of this new bridge, they put a sign right up to the bridge that said, "Our bank, whatever the name was, is as strong as a Tecumseh Narrows Bridge." Apparently, some managers in that bank had to rush to the very next day and make sure that sign was taken down before the film was taken. The town got nervous because right after the bridge was made, it was shaking like that, and they had tourists come all over the place, just experience this wonderful bridge that's kind of rocking back and forth all the time. And so they contacted a professor at a nearby university and said, "Could you come out and check things out?" And he said, "I don't need to check things out. I'll do models here at the university." He did a lot of models and proclaimed that the bridge was 100% completely safe. And when that last storm came in, they were so upset, said, can you please come out and make some measurements and make sure you're accurate with your conclusion?" And he was the last man on the bridge. Saying, "I don't care how far it's rocking, it's not going to fall." And he finally got the idea that maybe it could happen the minute he walked off the bridge collapsed. Really funny stories about that. Oh, one more. The governor of the state of Washington was so upset when that bridge fell. He said, "We were so proud of this bridge." He was speaking to the media. This is a public statement he made. He said, "I promise you, we're going to build that bridge exactly where it was, exactly the same way we did it before. We're not going to change anything." He immediately got letters from engineers saying, "You know, you do that, you're going to get the bridge falling exactly the same way it did fall before." Sorry, I'll come back. But you guys see my point, my first initial mistake? I want to choose my U and my DV in such a way that I eliminate whatever the problem child is if I can. And I certainly was able to eliminate the problem child, which I think was a factor of X, because without it I can differentiate, or excuse me, anti-differentiate PC headache. I know we need a break, but what would you do with this one? No, you guys relax. We're going to take a break in a minute. You let me do the work. That being the case, I think this is equal to the product of my u and my v, which in this case is negative x squared cosine of x minus the integral involving v du, which in this case is 2x cosine x. Did it work?
It Well, sort of, you could do another
I sort of
UV.
did, I mean, I
Yeah.
reduced the order of the exponent for x down to an x to the first power, it's just that maybe now I can
Do another one.
do it again.
Yeah.
And I'm applying integration by parts again. Here's my new u. I'll let u be equal to x. dv be equal to everything else. But that implies du is equal to dx, and it also implies that v is equal to the sine of x. And now applying my integration by parts formula one more time, that just simply leaves with a negative x squared cosine of x. Is that a plus x sine of x? But don't forget, I've got a lingering factor 2 on the outside. Minus the integral of my v du, which in this case is positive sine of x respect to x. But again, don't forget, I've got that lingering factor 2 on the outside. Or shall I say in the end, that merely leaves you with a negative x squared cosine of x plus 2x sine of x. You guys finish up. I said, you guys finish up. Plus 2 cosine of x. I like it. Are you there, sir?
Oh,
David?
yeah, if it was raised to the 10th hour, you'd be in for a really bad day.
No, I like integrating. It'll be fun.
Last semester when I did this, I always got confused when to do it twice and when not to do it, or more than once, basically. Like when to do.
Okay, you know what? That is a really good question. I don't think my example right here is really sophisticated. I promise after the break I'll get much more sophisticated. But one way to tell is that if you're okay anti-differentiating this particular transcendental function, and as long as it's just a power expression out front, I think you can always play this technique maybe 10 times, maybe 11 times, repeatedly to reduce the order of whatever that exponent is. So I finally whittled it down to just a constant so that I can now anti-differentiate that particular transcendental expression.
I have two kind of things. On your first substitution, was there a dx at the end of v?
I have no clue. Sir, it does not belong there. I was just writing too fast. I do need dx up here. It says relating dv to dx, but I certainly do not have a dx there. My apologies.
And when you do it the second time, never mind, I guess.
Sir?
What's the second step from when you get from
You mean from here to here?
No, the next one.
From here to here?
Yes.
You know, I simply said to myself, gosh, I just can't anti-differentiate that just like that off the top of my head because it's a factor of x. And that's why I came over here and applied integration by parts one more time. So this u and that dv came from these two. This is my new u and my new dv. And so now with integration by parts again, I replace this integral right here with these two terms using my integration by parts formula.
Oh, and then you have to multiply all that by 2.
I did. I just kind of said it out loud as I wrote it. So, sir, I really never finished answering your question. You said, when do I know to do it more than once? This is just one way for which applying integration by parts repeatedly helps me evaluate the original integral. Some other time, and again, you'll see this after the break, I might get something this nasty. Something times sine. Apply integration by parts, the same something's in there.
Yeah.
Times cosine, oh shoot, I still can't integrate that. But if I apply integration by parts again, I get another integral at the end involving something nasty times sine, and I can solve the equation involving an integral. And I'll give you an example of that right after the break. But that is another situation in which I would apply integration by parts multiple times, but I recognize it for a different reason. It's because I see the cycling motion, trading one integral for another that's just as nasty, but when I do it again, it comes back with a different coefficient, so I can solve the equation. I promise I'll work that one out. Yes?
Where does the second 2 come from?
That came from the fact that I really have this. You know, the 2 is being multiplied by the entire integral.
Okay.
So when I apply the integration by parts technique, I get this. I just skipped a step. I remove the brackets and distribute the 200. Because anybody else? All right. I've hardly touched it. I want to do something more significant when we get back. So let's take